Yeah.
Yeah. So recording is started. I would
Okay.
like to introduce
Okay.
Dave.
Good.
Dave here, who is let me handle mic to him so that he can introduce himself in a effective manner. Yeah. Hello, Dave.
Hello. Well, it's a pleasure to be speaking to you, and for those who I'm now with the U.S. National Geodetic Survey. I retired a few years ago as the chief geodetic surveyor, and I was exceedingly lucky in my career to have the background to work in basically all phases of geodetic positioning, triangulation, leveling, and now, of course, GPS, now GNSS. I was integral into the development of our national datums here in the United States, the current North American datum of 1983 for the horizontal, and the vertical datum, the North American vertical datum, 1988. And I've spent a fair number of years, probably about the better part of 30 years, in not only with the National Geodetic Survey, but also as a private individual now that I'm retired, helping to educate surveyors and GIS professionals on the importance of high accuracy positioning, because we now live in a world where it's basically a utility. Charlie Trimble, the founder of navigation, creates all the wonderful utilities. Charlie Trimble once said that what he called it GPS, now we commonly refer to it GNSS, Global Navigation Satellite Systems. Charlie Trimble thought of it as the next utility. So just like you might walk into a building and flip a switch and the lights come on, or you turn a tap and the water flows out, utilities such as that, and we take them for granted. High accuracy positioning is rapidly approaching that kind of level. It's integral to so many applications that we have today. Quite literally, and as I was just saying, if you have a cell phone, you have GNSS technology embedded in it one way or another, some better than others. But we are, again, rapidly, I know I overuse that term, but it is exactly what's happening. We are rapidly approaching a time when billions of people around the world will have access to a centimeter, if not just a few centimeter, almost instantaneous technology. Not quite instantaneous. We've got a lot of things to do to get down to that level. But the capacity of this for so many people to acquire relatively high accuracy geospatial information and to be able to share it with one another, to me, this is an incredible advancement, and one that, as we move forward, the development of geographic information systems, GIS, they're the individuals, the GIS managers, in my way of thinking, the GIS managers literally around the world. I don't care if it's at governmental levels, federal, state, local, governmental levels, private sector, doesn't make any difference. They are the ones who are going to manage most of this data. The average individual may collect a little bit here and there, share it with somebody else, but to manage it and make it usable, it has to be gathered together in some framework that can reliably bring all these data elements together. And we're challenged, literally around the world, we are challenged because we have tremendous amounts of legacy information, a considerable amount of it geodetic, or have a set of coordinates, latitude and longitude, or maybe GTM coordinates, or some other local coordinate system. So there's a tremendous amount of legacy information that exist in communities all around the world. And they often run into issues trying to integrate. How do I take what I have, which might be quite good? You've been building communities on it for years, but it was local. And now you want to go global. You want to use global reference frames to capture new data, whether it's directly through a GNSS receiver, maybe it's a high-end geodetic or survey grade receiver, which can cost, several $1,000s, or maybe it's a cheaper one that's embedded in a UAV, something of that nature. And we're capturing tremendous amounts now of data that way. What I find, and of course, the vast majority of my experience is in the United States, but I suspect it's pretty much true around the world. My relationships with organizations such as FIG, the International Federation of Surveyors, and various countries that I've worked with to modernize reference frames. What I have found is that the overwhelming majority of individuals who are managing this data, that is on the GIS side, are exceedingly well trained. Maybe it's academically, or it's a combination of academic and on the job, but they're exceeding software platforms, both those that are off the shelf, like Esri, or others that are homemade or developed at national levels.
Yeah.
And what I find,
Exactly.
Yep,
So,
regrettably, is that the majority of people who are managing a GIS often have only in understanding the basics, the foundations of the geodesy.
Yeah. You're saying,
You almost can't. Sure.
Yeah. And Dave,
That's all too common.
Yeah. Can you please enlighten some of the points, because you are the GIS and survey veteran, and you have seen the switch of non-GPS surveying to GPS surveying, and now enhanced GPS surveying. When we do have, like you have mentioned, that we are having very precise GPS locations in 2025, and more of the constellation of GPS is going to be launched. So how you see the difference of non-GPS to GPS affected survey? So can you please highlight on this chapter, because this is something that most of the guys who are recently graduated, or most of the recent GIS or survey students, they can't feel this specific aspect. So yeah.
Sure. Well, we have so many tools available to us now, so many measurement tools that are quite easy to use, and virtually, certainly robotic instruments. And it doesn't take very much education to learn how to run any of these tools. I don't care if it's a GNSS receiver, if it's a robotic total station, or it's a digital barcode level. All of these things are incredible instruments, vastly superior to anything I grew up with, originally anyway. And now they're in the hands of people who can quite easily push a button. That's not a problem. Get numbers, not a problem. What do the numbers mean? How do they fit together? So we live in this world that's not only can we acquire that data easily, and we can start to manage it in a GIS, whether it's governmental or private or public sector, it doesn't make any difference. how do we start to manage now, especially if our expectations are at the several centimeter level, which is essentially what they are? How many of these utilities, these GIS utilities, how many of them are designed at their heart, at their foundation, to deal with the fact that we live on a dynamic planet? Everything is moving. Everything's moving all the time. Now, I know you're from Pakistan. I do not have to explain this to you. You know that, right? It is part of your world. It is part of everybody's world. Even if you live in the middle of Kansas here in the United States, where we have no major tectonic issues, the fact is it's still moving, right? So if we're going to capture this data, I think we have to have a number of elements in place. First, and hopefully this can be developed at the national level, although I know quite a number of national institutions, national surveying and mapping institutions are challenged for lack of resources. I understand that. I've worked in many countries around the world, and I know, being able to say, oh, go buy some GNSS receivers and establish continuously tracking stations, that's quite an easy thing to say. It's a whole nother thing for any number of these communities to be able to do that and maintain them for the long run, which is exactly what has to happen here. So since you are in Pakistan, I have that correct? Is that right? You were in Pakistan?
Yeah, exactly.
Okay.
I belong to Pakistan. Yeah.
Okay. Well, I did a little bit of research after your email, and I am unable to find anything online that the National Survey in Pakistan has any network of continuously operating GNSS receivers. Now, obviously, I could be wrong because they could have it. It's just not online. I can't find it.
You
if
are
we're
right.
going to live in this world,
you are right. But they
okay.
they are establishing it, and
Cool.
in
Good.
cooperation with China. You are perfectly right. Right now, Survey of Pakistan is actually dealing all of these aspects, and yeah, we have things in place, but I do think so that it will take a few years to be to be completed.
And therein will lie the challenge, because you're going to have people who are out using these technologies right now, whether they're the high-end receivers and they want to go and sit on a point for several hours and collect data. And so let me use that as an example. You can achieve a few centimeter receiver right now in Pakistan, because there are stations literally around the world. Your neighbors over in India have 1, 2, 3, 4, what did I remember seeing? 4 or 5 continuously active stations. I'm sure they have more, but they have 4 or 5 that are part of what's referred to as the IGS, the International GNSS Network, that are available to anybody in the world. And so a surveyor or someone else, who wanted to get high accuracy positioning in Pakistan could fairly easily go out with their receiver, and as long as they're willing to wait several hours, because that's what it would take, since these stations would be quite a distance away, they can again easily process that data if they don't know how, because it can be complex. But there are online tools. So you could take that data, a surveyor in Pakistan could take their GNSS data. If they have at least 2 or 3 hours of that data, they can get online. They can send that data to the Australians. They have a utility called AUSPOS, AUSPOS, quite easy to find. They can send it to the United States. We have a utility called OPUS, O-P-U-S. It takes in the surveyor's data and typically in about 5 to 10 minutes sends them back a data sheet, says, hey, here's where you are. Here's your coordinates. Here's your latitude and longitude, or UTM coordinates. And they will give you estimates of the accuracy of that. So we now have these tools. In fact, you could send them to both. I give classes from time to time on this, and I tell surveyors here in the United States, because I know they don't know how to process that data. You know, they don't know the mathematics behind it. They rely on somebody else. And they're always cautious about relying on one source, even if it's the United States National Geodetic Survey. I'll tell them, hey, take your own data, send it to Australia. You're going to send it halfway around the world. And again, within 5 or 10 minutes, you're going to get a set of data back that will match within a centimeter or so what NGS is giving you. So now you have a confidence factor that's built in. Now, once you have those stations online in Pakistan, okay, now you don't have to wait 2 or 3 hours. Now you can be down to a few minutes. Or if you have enough of a network and it's real time, you can literally be down to almost a few seconds of data and be able to maintain.
Dave, that is amazing.
Yeah, oh yeah, it's insane. It's quite insane. And so that's where things are headed. Now, once that happens, that's where, to me, the surveyor and the GIS manager have to be at least basically, fundamentally familiar with the geodetic datums. What are they? How are they defined? And how are they maintained? So again, I did a little bit of research for Pakistan, and the most current reference frame.
Oh my God!
You know, the most. Well, it doesn't take much, you know. But what I find is that the current national datum, and I believe this is correct. I could easily, you know, if I'm wrong, I could easily be corrected on this. But the reference I find is called the Kalimpur 1962 datum, horizontal. I don't know about the vertical. Vertical's a whole nother thing. But it's based on a size and shape of the Earth that was originally defined by Everest back in the 1830s. And then it was updated in the 60s.
Yeah, exactly.
And that works just, I'm sorry, go ahead.
Yeah, you are saying it right. And we don't have any kind of a specific datum that is established, and we can't use it in QGIS or ArcGIS. Yeah, right. So we use just WGS 1964. And
WGS 84. Don't go there. Do not go there. Not WGS 84. Please, please, please. Okay. Let me let me talk about WGS 84 for a second. So what you have in Pakistan and many other countries, Pakistan is not alone on this. This is what we were dealing with in the United States back in the 80s. We had a datum that worked very well from point to point, all the mapping and charting. It did well, but it was not designed to have its origin. Its origin of coordinates was designed at a survey mark out in the middle of a farmer's field in the middle of the United States in Kansas. And all survey marks related to that one survey mark. So now we move into the world of space-based positioning, and you want to be in the same coordinate system that satellites are in, not some survey mark out in the middle of some farmer's field somewhere. So that means you have to have a system, a national system, in which the origin of your coordinates is geocentric, or is as close to geocenter as you can possibly make it. And today, with all of the global interaction and science that we have, we know Earth geocenter to within about 2 centimeters. So it's a pretty vibrant environment that we're in right now. And so the big transition that Pakistan will have to go through is, once they have these cores and they can go out and do high accuracy GNSS measurements, they will have to develop a new geocentric datum. And then hopefully perform a number of operations in which they can provide a datum transformation, an accurate one, for all of the legacy data, all the historical data. That's a tough project. That's a big project, that a country has to deal with. So you've got to have staff to do it. You've got to have talented staff that know how to deal with this. So in the context of what surveyors and others are doing now, you mentioned WGS 84, and I am not at all surprised by that. It's often referred to that way around the world because the global positioning system, that is WGS 84, is the default coordinate system defined by the US military, the US Defense Department, for the global positioning system. Okay. The problem is you can't get centimeter level accuracy out of WGS 84 because there's no ground control. There's no ground control that we as civilians have access to. If you're in the military or you're connected with the US military, yeah, you can probably get that. Or if you have military grade receivers, yeah, you can get something. But the rest of us, nope, we're left out. We don't get that. You have to have a ground frame network to determine those high accuracy positions. I don't care how many digits to the right of the decimal point come out of your receiver or out of your computer, whatever it is that you're doing. And I hear people going out and buying receivers, and they get their information about how it works from whomever they bought the receivers from, whoever the manufacturer was, right? So you've got a distributor who sells you Trimble or Ashtec or Topcon or Javad or whatever it is you're buying. It doesn't make any difference. And they will tell you, all this data is now in WGS 84. Okay. If we take that as an absolute for a second, what they never tell you, because regrettably, they don't know, that is the people who are selling this equipment, is that WGS 84 has changed 7 times since it was changed 6 times since it was done. So there's 7 different developments of WGS 84. Now this is very logical. The US Defense Department, like the National Geodetic Survey, realizes they want high accuracy positioning. So what they had to do is they had to go through a process every several years of reorienting WGS 84 for a whole range of different reasons. So for example, if you are going out today and trying to achieve, you thought you were achieving several centimeters in quote WGS 84, the metadata, the real metadata, should be WGS 84, that part's fine, open parentheses, G, the letter G for like GPS, followed by the number 2139, close parentheses. So it's WGS 84, G 2139. That's the current realization of WGS 84. Almost no one in the civilian sector ever hears about this stuff. And there have been 6 others like that. And so if you're collecting data and you think you have high accuracy and you don't have the right metadata, which realization of WGS 84 was I really in, and how good was it really? That is, at the 95% confidence level, how good is my position really? Not, again, not the number of digits that come out of the computer or out of the data collector. Once we get to another environment where Pakistan will have a national datum, and it will be very precise and very Earth-oriented, and it will be related to the global framework, you want an accurate transformation. But if you don't have the right metadata, you won't be able to perform that right transformation. So anybody who's out there today that thinks they have WGS 84, in reality, what they should do is say, nope, First, let me back up for a second. We are, and I think I might have mentioned this when we first started talking. We are no longer in the GPS world. We are in the GNSS world. We have the US Global Navigation Satellite System. We have GPS. We have the Chinese Beidou, which is very strong. We have the European Union Galileo, also very strong. We have the Russian GLONASS. It has some issues, but nonetheless, it's part of that. They have some tracking issues on parts of the world. They don't have a good tracking network, at least on this side of the world.
Yeah, and some of the
but you have at least
sorry to interrupt you. Some of the regional GPS, Indian GPS as well. That is regional, and also the Japan's one. Yeah, we do have these. Yeah,
right. So you have regional reference frame also that supplement these. So in the United States, we have what's referred to as WAAS, WAAS, Wide Area Augmentation System, which is defined primarily for air and marine navigation. So it's a complement to it. But the foundation is the national datum. In reality, anybody who's out there today positioning themselves, first of all, if you have a receiver and it's getting at all four, more than one constellation, doesn't have to be all four. Maybe you're getting just GPS and GLONASS, or GPS and Beidou, or GPS and Galileo. It doesn't make any difference. Everybody's got at least two. Well, then how can you say your data is in WGS 84? That's only related to one of them. The Chinese Beidou isn't in WGS 84. The European Union Galileo is not in WGS 84, and the Russians are not in WGS 84. Everybody's in their own local coordinate system, their own global coordinate system. They're all the key, and there is a key. The key is they're all related to the International Terrestrial Reference Frame, the ITRF. That's what everybody wants to be in. That's what data should. I don't care what your receiver says. Your receiver might say, oh, I'm in WGS 84. I would be turning that around saying, okay, fine. That's what my box says because it comes from some manufacturer. But the reality is it's in ITRF because even the US Defense Department already says that the current realization of WGS 84, which I mentioned, WGS 84 G2139, is centimeter consistent with the ITRF, the International Terrestrial Reference Frame of 2014.
Perfect.
So right away, the Defense Department is saying, oh, this is what you really should be using. Yeah. They don't talk about it that way because they have their own things to deal with.
Dave, we do have.
Oh, I know this gets complex. I got that.
Yeah. Sorry to interrupt you again, Dave. We have
no.
Yeah, one minute left. Can you do you want to send me another Zoom link for this, or you want to complete in this 1.5 minutes? So I would like you to explain furtherly, because sooner or later we are going to send this whole recording to someone at a very high table in Survey of Pakistan as well, and I'm sure that these insights that you are talking about, they will create impact in whole of the Pakistan's GIS community. So I would certainly hope that the Pakistan survey is working globally. I would hope that they would know the ITRF and the IGS, because you would want to have at least two of these new stations that Pakistan is putting up. You'd want them to be part of the IGS, and that's not that hard to do. It's quite open to global development. One thing I can add, for those who don't have much of a background in this, there are a number of YouTube videos that myself and another guy from the National Geodetic Survey, David Zilkowski, the two of us put together several YouTube videos that are available, just little 1 hour short things on fundamentals of geodetic datums. And I've got one out there on WGS 84 and datum differences. And